There you go. So we're going to talk about functional error handling in Kotlin. But before we start, I would like to ask how many people are actually using Kotlin at work? Here? All right, quite a few bunch. And how many have at least tried it or used it a little bit? All right, pretty good, pretty good. All right, then you're set for a good journey, let's say. So my name is Tonino Catapano. I consider myself a full-stack developer, even though, yeah, not a lot of people think that this creature exists. My favorite languages are these two, so Kotlin and JavaScript. In my free time, as Michael was saying, I'm a FPV drone pilot, so I build and fly this type of drones, very fast-going drones. And recently, I started doing climbing. And here you can see me in Italy while I was doing climbing. You can find me online pretty much as anywhere as Tonnots. All right. So as you see here, we're going to go into a journey today on an iceberg. We're going to start from the depth of the ocean, and hopefully we'll go up till the surface. And also along the way, we will encounter some interesting sea creatures, maybe. So let's start talking a little bit about functional programming in general. So what is functional programming? Functional programming for me is about building software using pure functions. Pure functions means that they have no side effects. What does that mean? It means that if you have side effects, usually you modify data that you're not supposed to. Or for example, you modify data structures in place. So all those voids methods, those unit methods, those are one example. Even input-output is a form of side effects, and surprise, surprise, exceptions is also a form of side effects. Why do we want functional programming? Well, because we're human, we make mistakes, and functional programming helps us to make our code easily more testable and makes less mistakes. Here we have two examples of code that do exactly the same thing in Kotlin. On the left side, there is a more imperative approach, and on the right side is a more declarative style approach. And as we can see, the left part is more characterized by keywords like var, for, if, and mutable sets, mutable lists. Whereas when we talk about declarative or functional code, we often talk about filtering, map, for each, immutable, and laziness. So it's easy to spot that the code on the right is way more maintainable. We clearly state what we want from the compiler. And instead on the left, we go more into the nitty-gritty. We instruct the compiler on how to do the stuff, which is a bit out of style, let's say. So in short, functional programming promotes immutability and pure functions. We can lead to more testable code. You have more compile checks, and therefore you remove all the loops of like, oh, bug in production, I gotta fix, or more testing needed. And the last part allows us to explicitly define handle success and failure case in your code. We're gonna see more about this soon. Some functional programming terms or some monster that you usually hear when you talk about functional programming is high-order functions, functors, monoid, category theory, monads, lambda calculus. We are not going to talk about any of this today. This is pretty much just like straight code. But I want to tell you, if you're a Java guy, you definitely use some of these. So monads is every time you dealt with optional, stream, completable, future, project reactor, those are all monads. Every time you use a flat map in your code, that's a monad. It means that that data structure, that object was a monad. If you want to learn more about this, there is this great talk by our guest today here, Urs Peters, which I think is the best introduction possible that you can have to functional programming in Kotlin. So absolutely go check it out if you want to know more in general about functional programming in Kotlin. So we are at the first stage here. We can talk a little bit about exceptions and nulls. So what is an exception? Well, an exception is an event which occurs during the execution of a program that disrupts normal flow of the program instructions. When I think about exception, what is your the first exception that you think of? There you go. Null pointer exception. So the inventor of the null reference, Tony Hoare, defined it as billion-dollar mistakes. Because after that, in 1965, many other languages decided to use this approach, which led to countless hours of us debugging in production. And here we have a picture of a null pointer exception. So if you're a Java guy, sooner or later you must have written code that looks like this. So a lot of defensiveness against these nulls, so either with if-elses or with try-catches. If you wrote this code, well, I'm sorry for you to give you this traumatic experience, but it is what it is in Java. Also still, if you did Java, probably you heard about checked exceptions. And I want to tell you that are evils. Why do you think checked exceptions are evil? What is your take? Well, it's evil because every time you declare a checked exception in any piece of your code, if it's a very deeply nested code, if you change anything, refactor something, you need to change all the chain of calls up to the caller. So it makes quite hard to change your code. And languages such as C++, Scala, and Kotlin do not support check exception at all. Also, if you use Java streams, it's a nightmare. If you ever use them, you need to rethrow them as unchecked exceptions, do some magic over there. But what I found useful was to use this library called Joel or Joel Lambda, which helped us a little bit with these cases. So let's take a break, and because it's after lunch, let's just watch a little funny video about exceptions.
Programming joke of the day. 3 errors walk into a bar. The bartender goes, normally I throw you guys out, but today I'll make an exception.
I must be an exception, because you have sure taught me. No, because basically in programming, when an exception occurs, it needs to be caught or handled by the programmer. You caught my exception just in the same way exception is caught by exception. Get it?
Okay, so do not use exceptions, pickup lines, not recommend. Yeah, let's get more serious now. Let's try to design a program that, given a consultant, will return the best matching client based on their skill set. So if we imagine a very simple data model, we can have, for example, an assignment and a consultant. They have a name, they have a stack and skills, and you can see that this is where we're going to run the match against. So stack and skills are basically kind of like synonymous. And then we have a client name for the assignment. We can fake a database as so just a set of assignments, and of course we can have a consultant such as so with a set of skills, with a name, etc. Now, if we try to think about the algorithm, we might think of something like this. So, for example, get the assignments that have at least one matching skill for the consultant, sort by the max number of matching skills, get the top assignments, and return the client name. Now, a question for you. Do you think we have missed something here? I give you a hint.
Next by, right?
So every time that we have any type of problem to solve in our job, there is always an hidden requirement, which is design blah, 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 but also handle errors when something goes wrong. So we always need to keep this in mind, and sometimes we forget about it. So let's just see it in practice. Let's do some coding. Wish me luck. All right. All right, can you see it? Is visible? All right. So this is exactly the example that we were dealing before. So we have an assignment and a consultant. We want to match a consultant based with the skills that he have based on against the stack of a possible assignments. So we have a very small database with 3 assignments, one for aviation, banking, and e-commerce, aviation client, banking client, e-commerce client, that have 3 different stacks in their jobs. And what we want to do is solve this. So we have 3 layers: data access layer, a service, and of course a main. And we want to try to solve this problem. So just like we said before, we can do assignment db.filter it.stack.any. And here we want to check that our consultant, this is a skill. So we want to say that the consultant.skills must contains the skill. So this will make sure that we filter out all the assignments that don't have any matching skill at all. After that, what we want to do is just get the one that has the max number of matching skills to a stack. And we can do this with this operator in Kotlin, which is really amazing. It's called intersect. So we can intersect the stack set to the consultant.skills. And from here, we want to get the size, so the biggest one. Now, we're not done yet because this is max by or null, could be potentially null if we don't find anything matching. So we need to handle the case of null. To do that, we can use an operator in Kotlin that is called Elvis. So in case we don't find anything, for now, we can just throw no such element found exception, and we can say no assignment found. Of course, we need to return it, but we can also make this an expression, so it's a little bit better. We don't need the return statement. Assignment. In our service become at this point straightforward because we just need to call our DAO and says, okay, pass the consultant, and then from what we get back, we just want the client name. That's it. Again, we can transform this into an expression, so we don't need the return keyword. And when we run this, we have 2 consultants here, one that has C++ as a skill set, and we have no matching skill set as C++, and another one that has Spring and Java, which perfectly match the aviation assignment, the first one. So if we try to run this code, as you might expect, we get our exception. So no assignment found. And we notice our first problem with exceptions. If we forget to catch exception, it halts the program. So the second line here was never run at all. So of course, as good Java developers, what we can do, our try catch. No such element exception. And we can even output something. We can say no assignment found again, and then we can return a default value, for example, not found, something like that. All right. If we try to run again, it's a little better because now we get to the second consultant. But I mean, this is not the best. I mean, best assigned to client not found. Meh. Not the best. And okay, at this point, I would like you to introduce to a very important concept in the functional programming world. Let me just try to refactor this real quick, like this. So this is an assignment. So the concept that I would like to introduce you to is called referential transparency. So what is referential transparency? Referential transparency says the following. At each given moment, if we replace this function call with this return type, our program should still continue to work seamlessly. What does that mean? It means that if we take literally one of these assignments and we put it here, like this, then the code works, right? But our function can throw an exception. So what happens if we put an exception here? Bang. You see this red? It means that there is a compilation error. And this means that this function is not referentially transparent. So how can we do better? How can we restore this property? Well, one way is to not throw any exception here, but make use of nulls. And if you think about Java, nulls are evil, right? But in Kotlin, they are not. In Kotlin, the null feature is embedded in the language, and it's type checked, which means we can do really cool stuff with it, and it's not evil anymore. So for example, if we put a question mark here, our code compiles again, and it means that this piece of code, this assignment, might be null. So there is a question mark at the end. If we see here, already our code tells us that now this doesn't work anymore because might be null, so we need to do something about it. So we can put a question mark as well here, but there is still a problem, because what happens if it's a null? You still haven't handled with the case. So again, we can use the Elvis operator and says a default value. So we can say, I don't know, not found, something like that. Of course, we don't need anymore the try catch. And there's still something wrong. This one is not okay here. We need to return it straight away because I'm doing it this way. Okay. Pretty cool. So at the moment we restored referential transparency because we always have a maybe assignment. But what happens if we run the code? Well, we lost context about our error. So now we have a message string that says not found, but not much in that. I don't know why, what happened, what was the consult that triggered the error, etc. So probably we can do a little bit better than this, but if I remember correctly, now we have a little bit of a break, or maybe not. Wait. Yeah, so there is first another piece of code that I would like you to show before we go into a break. So this is a different version of the same program where now we have also a new class that makes a cascading call. So after fetching our best assignment for our consultant, we also make another REST call, let's say a fake REST call, that checks if that specific client allows working from remote. Just an invented case. And this is the call. As you can see, in case it's an aviation client, it's going to return true, otherwise false. We also simulate some timing for the delay of the network. But what about this piece of code here? So one time out of 3, we're going to fake an input-output exception. Remote service is down. So now let's try to modify the code that we had before, and actually to create a new function to have this cascading call. So instead of returning the string of the client name, we basically return true or false if this client accepts remote working. Well, pretty straightforward, just like before, consultant. Then from there, we take the client name, and from there we can use a construct that is called let in Kotlin. This let take in scope the variable take in scope the variable that we're calling with, so client name. And here we can make the call to our accept developer with it, which is our string of client name. Of course, there is still a problem, And the problem is that we haven't handled with the case of null. So again, Elvis operator, false. So we shortcut everything to false. One thing to notice, this is very important, the let call is done only if we have a value. So if our client name is null, we never call this. We shortcut it to false. All right, let's try to call this code. Remote service is down already. So we have some issues. If we try to call it again, for the first one, it went straight away to false because there is C2 first, which has C++. And the second one went again service, remote service down. Wow, today's all service down. Wow, okay, we're very unlucky this time. Ah, there you go. So now it worked. But my point is that we reintroduce again some error. The code is again halting because we're making another type of error, like an input-output exception. So something that we cannot really control. All right, so now let's take a little break. I wanted to show you that even Yoda does not recommend to use exceptions for control flow, believe it or not, because he says do not, do or do not, there is no try. What did we learn so far? Not catching an exception might be evil because we have unwanted halt of the program. Exceptions are a kind of a side effects. The question mark operator in Kotlin helps us restore referential transparency, but we lose context about the error details. When the code becomes more complex, like with a chain call, we start to see a lot of defensiveness against null. So we saw all those question mark dot Elvis operator. So it was quite defensive. And finally, we noticed a difference between a real exception, like a network failure, and logical failure, like element not found. Can we do better? All right, so if we move up in our iceberg, it's time to talk about railways and results. So if we look at the code that we wrote so far, it looks like this. Our question is there an optimal remote friendly assignment for a consultant? Our service will call our data access layer, and our fake database will search for matching assignments. In case it doesn't find anything, we just return false. In case the assignment is found, then we proceed with a chaining call, and we call the accept remote developers that might return true or false, but can also throw an input-output exceptions. So this is a very simple case, and you can see that we already have so many lines. And so my question is like, how can we have pure functional code if we have many different exits and return types all over the place? So we need a way to reason about code that is a bit more streamlined, a little bit more simple, if you want. And while I was doing my research for this talk, I found this amazing way of thinking about code that is thinking in railways. So if we think at our functions as railways track, we can see them always at either one-way track or two-way tracks. One-way track is like, for example, in this function here, we have a one-way track function input that will become as a two-way track, either a success or a failure. The cool thing about this way of thinking is that makes it really easy to understand how to compose functions, because functional programming is all about composing functions together, chaining them together, and making transformation over data. So this way of thinking, for me, is way more easy than what we saw before. So for example, here we have a function f1 that given a one-way rail track, transform it into two, so a possible error or a success. Function number 2 instead does nothing. If was an error, continue to be an error. If maybe does some sort of transformation but cannot throw an error. Function number 3 can throw an error, so there is again a fork. You see that can become again in an error. function number 4 does nothing. So this is just another example. I'm not going to go into the details, but what I want to point out is this part. Oh, too much. Oh, oh, oh. What happened? I want to point out this part here, which is important because every time we work with two-way rail tracks, at the end of our journey, we always want to return still one message. So for example, if we are doing REST services, we want to return one JSON, which will contain either a success or a failure, but still one. So this that I just described is called success or failure union type, and is present in many functional languages nowadays, including TypeScript, for people that hate frontend. And if your language has it, you're very lucky because it's super cool. And spoiler alert, we can do it also in Kotlin. And all these pictures that you saw are from this other talk called Railway-Oriented Programming from Scott Blashin. It's a talk from 2014 at NDC London conference. I absolutely suggest you to check also this one out. Still a banger, definitely check it out. The code is in F# in the talk, but it's totally understandable. It's pretty much like pseudocode. So what about Kotlin? In Kotlin, we can reason about railways as with the result data structure. So the result class in Kotlin model exactly this scenario. So given a function, we return two things, something that can be either a result of a success or of a failure. Here you can see some of the methods, some of the functions that come with the class. There are a lot more. We will explore some of them, and these functions allow you to write very beautiful functional code. One thing to notice that is important is that in the failure scenario, we always have a throwable. So this means that we will always have an exception in our failure scenario. And it's kind of a restriction, but we will see what we can do about it. So let's see it in action. So the code is exactly like before, nothing has changed. The only thing that has changed is the signature. Now we have a result of a string. How can we return a result of a string? Super easy. Just do just like before. Try catch. No such element exception. And here we call our assignment DAO. And we can make a return. Find best matching assignment for consultant, and then from there we can get the client name. We rolled back to throw exceptions here. That's an important thing. So it's not exactly as before. And in case it's a problem, well, we just return result dot failure with our exception E. So this will be a result dot success. There you go. What is it? Doesn't like return. All right. There you go. So this construct is so common within using results that the guy of JetBrains created this beautiful method, run catching, that does exactly that. So we can get rid of all this boilerplate code and just have this. Remove also this. Bang. We're doing exactly the same thing. So how we can change the other call, the chain call. So let's try to do that as well. Just like before. Consultant, client name, and then we do let call. here we call remote client. No, I'm confusing myself. Okay, so let's try to use what we just learned. We can do also run catching with this call. But now I kind of want to change what's in my container, what's in my result. So I can use the map function to say I want the client name. And now I can use again the map function to call the remote client checker dot can't allow remote with it. So this code works, but we have an issue. If we remember, this call might trigger an input-output exception. So in this case, this code will break, and we will just throw the exception at the caller. So we have a problem. But this is very, very easy to fix. We just have to swap our map with map catching. And this map catching under the hood is doing basically a run catching and checking that we have no exception in there. So now we are safe. If there is like an exception, we will just be caught by the result. Now, this is very cool, but what I think is the best part of using results is on the consumer side, because we have all these beautiful functional methods that we can use. Some of these are like on success and on failure, where we can do some sort of side effects with our result. But we also have the recover method that allow us to recover from a failure into a success. The recover method is a little bit dangerous because here is what you do in terms of recovering to a success. But on this line, the last block, if you throw an exception, is not gonna be caught. So if you want this this last block to be also safe and be captured by the result, then you need to use recover catching. Another thing that I want you to notice is that we can use the when expression over the error type. So that in case we have an input-output exception, we do something, but if we have a no such element exception, we do something else. And we can also try to run it, why not? So we see now the code is working, and for the first one, but for the second one, we got an input-output exceptions. So we went into the input-output exception. Now there is a problem. This looks amazing. I really like it. There is a problem about this. Is simply this. So do you see? I commented out one of the possible error case scenarios, but our compiler doesn't tell us anything. So it's fine. And the reason is because results use a throwable, which is a very generic class, very generic inheritance. So we might very easily miss an error case to handle. But we will see, maybe there is a way around this. So let's go back to the slides. So what we saw so far, results looks amazing. Let's use it for all our errors. Looks so cool. Maybe other people might think it differently. Think like, hey, it's just an exception wrapper. No big deal. What is my take? My take is that result is a good alternative to try catch. It helps improving the semantic of our code with pre-built functions such as get or null, recover, and fold. But it's not perfect. It encapsulates everything as a throwable, what we just discussed. So it's easy to miss an error when you're dealing with the consumer side. So in general, I don't recommend to use results for a business error or functional error, but it's okay for disruptions like input-output errors.
And another thing I see here is that basically we want to always do a map catching, because you don't know if a function throws an exception or not.
Yeah, well,
they are not checked, so
that's true, but it depends. Maybe you do not want to catch that also into our results. Maybe you do want the program to break. So maybe sometimes it's a...
Yeah, but you don't know up front.
Yeah.
So you cannot see from the function signature that it will throw a runtime exception.
Yeah, that's true. That's
so
true.
this becomes very hard for this concept.
Yeah, that's true. Especially if you're dealing with external APIs like libraries or third party, especially if it's in the Java world where you might have nulls going around, that becomes a little bit more tedious. So you need to be a little bit more defensive. But if you write your own code and you, for example, write a library that you can give to somebody else or even to your own project, I think a result is okay. So you can use it to define your own boundaries, let's say. And for more info, please check this link. There are all the possible use case for results written by JetBrains itself. It's a very good document on Git. Check it out. So, we are finally at the top of our iceberg. And what do we see? Oh, that's an arrow. So we have Arrow. Arrow is a library for Kotlin, and it's an idiomatic functional programming library. And it offers a lot of things that help you in your journey in the functional programming in Kotlin. These are some of the features that I checked out. Today we're going to check only the either one, which is here. But go ahead and check the rest because it's really, really good and can make your life much easier when writing functional code. So either. Either is pretty similar to results, actually. The only thing is that you have this error and success case separated in two types, as you can see. And the only difference is that you can define whatever you want as an error. So instead of using throwable, you can define your own class, whatever, your own object as error. And this is very important because it allows us to use another feature of the Kotlin language that is called sealed classes. So with sealed classes, you can define, as we will see, a set of possible errors that can happen. So kind of like a hierarchy. We will see it soon. So let's see it actually. So we go here. Oh. So this is what I was talking about. With either, we can define an interface matching error and then define data classes that extends on this sealed interface. And the compiler will know that every time we're using matching error, it's for sure either no matching assignment error or generic error, no other thing. Not like before there was throwable and it could have been basically everything. So let's try to use Arrow. Let's see how it works. Let's try to first use this one. I hope I do remember because I'm a bit tired. So let's see. We call again the assignment DAO dot find best matching assignments with the consultants, and from there we want to get the client name. Now the convention with either, as you saw, there were two slots, one on the left and one on the right. So usually on the left part you match the error, and on the right you match the success case. So right is right. It doesn't have to be that way, but that's the convention. And also, once you import the ArrowCo library in your class, in your project, you have available a lot of extensions, functions that you can use. So you can just do, for example, if I want to map this object, this value, as a right value, so as a success value, I can just do .write. Now, I don't think we are done yet because we also need to handle the left side. So what happens if there is an error? And also, this one is a maybe. So we need to change something. First thing first, this is a maybe. This is a maybe. And we want to deal with the not so good. In the case it's a null. Well, we want to have our no matching with a consultant, right? So we can do this, we pass our consultant, and we can wrap this into a left. Okay. Yeah, so here we are looking for a boolean, but at the moment we are still in a form of a string, so we still need to do something else. Yeah.
Before the right, I would say. No?
Yeah. Well, we can do it either before or after. So let's try to do it after, actually. It's a bit more interesting. So we can use the map function, and we can use the remote client checker dot client remote, and now we are dealing with a string because we're using the map method. Here also we need to have the question mark, and we can use this. There we go. So this works, but we do have an issue, the usual issue. So this call might throw an exception, so we need to do something about it. And what we can do is, of course, use a construct called either.catch. And this is pretty much similar to what we saw before. In case there is an exception, we can basically use the map left to say that we care only about we want to tell explicitly what to do in case of an error. And in case of an error, we want to have the generic error here. And the cause can be anything, like, oops. And the throwable is going to be just itself. There is something still not okay. Yeah, exactly. So since now this is itself an either, we cannot use map anymore, but we need to use flat map. And there you have it. So as you can see, the code is not that nice anymore. We have this write happening. We introduced this new monster flat map monad here, and yeah, again there's this catch, etc. So is there a better way to write this? Turns out there is. So either offers also the possibility of to use what they call builder scopes, which is really cool. And basically by writing this, which in other languages, if I understood correctly, is called monadic comprehension, we can write code that is way more linear and more imperative-like without doing all this flat mapping. So let's see how the code changes by using this. Well, we can do just like before, our call to consultant, and from there we get the client name. Let's put this in a variable. Let's call this client name. One thing that we want is this might still be null, right? Because this method returns a maybe assignment, so it can still be null. What we can do is use another method from either called ensure not null on client name. And basically these methods will tell to the compiler that if client name result as a nullable type, as a null, halt everything and just return a left, so a failure. And of course we need to specify what type of error, and of course we want the no matching assignment for the consultant. So we just write no matching assignment for consultant. At this point we can just call again the remote client, how was it? Remote checker client dot client allow remote for client name. Now, there is something that I would like you to notice. Here, client name was a maybe string, so it was a nullable type. After we applied this call, we can use it without the question mark. So this means that this allows us to do a little bit of flow typing, which is really nice. So the compiler understands after this line, our client name is not anymore nullable, which is pretty cool. And of course, well, just like before, we have still the problem with the exception. So unfortunately, we still need to do the catch scope or function. And we still need to do the map left. And we still need to do the generic error here. Now, this is still not okay. And the reason is because just like before, we have now neither within a neither. So if we look at what we are returning at the moment here, we see that on the left we have, I don't know if it's visible, but on the left we have a matching error. And on the right we have another either, whereas we just want the Boolean. So we kind of need to do some sort of flat mapping. But since we're using the either scope, now we can do what is called a bind. And with this bind, we are just getting rid of our errors. So here you have it. These two pieces of code are exactly equivalent, but we got rid of the flat map and a lot of these question marks that were floating around. If we try to run the code, well, let's first give a look what we have here on the consuming side. It's pretty much like before. So we have on left, on right, very similar to on success, on failure. We can also do a when on the either type to check if it's a left or a right. But there is a big difference. The big difference is this one. So now, when we do the pattern matching over the error type, if we comment this out, here we get a warning. It says, hey, you forgot an error to handle. And that's because we used a sealed data class here. This allows us to define a single place where you define all of the error that you need to do for that specific part of the code, and it makes your experience as a developer 10x better, I would say, or something like that. So again, if we run this code, we can see that it works, just like before. We got either an input-output exceptions, or in case it works, there is at least one client, so it's saying this line over here. And yay, yes, it's about this one. All right, so I'm a little bit over time, but these are my conclusions. A recipe for functional error handling in Kotlin. Use the question mark Kotlin nullability operator to represent the lack of a presence of an object. Do not use optional or other types, other monads. Try to not throw exception in your code, and wrap external API calls that can throw exception with run catching or either.catch. And my preference is first try to use either, because what we just saw, then results, and then finally, if you really cannot and you don't want to deal with all the problem, just use exceptions. Also think in railway-oriented programming about your monads. So always see your code if you want to use these types about shoe tracks, and try to map it and change the formats from one way to another. That really helps. And finally, have fun with it. This was my talk. Thank you very much.